The table shows details of the particles present in an atom of potassium and in ions of potassium and sulfur. Now, we are to determine what are the values W, X, Y, and Z. So you see the word atom. So let's recall, what is atom? We know that elements are actually made of tiny particles, and we call these tiny particles atoms. So each element actually only consists one type of atom. Atoms are the smallest particle of an element that has the chemical property of that element, and they are electrically neutral. This is a pictorial representation of an atom. Atoms are actually made of 3 different subatomic particles, and we call them electron, neutron, and proton. Protons and neutrons are in a dense center that we call a nucleus. Electrons move around the nucleus in the electron shells. The mass of electrons is negligible as compared to the mass of protons and neutrons in the nucleus. So now, just now I actually mentioned that atoms are electrically neutral. Well, that means the number of protons and the number of electrons must be the same in an atom. So in the question, we have the table that shows the details of the particles present in atom of potassium and in ions of potassium and sulfur. So let's focus on potassium first. Now over here in the table, we are given the proton number, which means the number of protons in the atom. Okay, so there are 19 protons, and the nuclear number is 39. Now what is nuclear number? Nuclear number is the mass number, and it is the number of protons plus the number of neutrons. So number of neutrons will be the mass number or the nuclear number minus the number of protons. Now again, the mass of the atom is contributed by the proton and neutron. The mass of electron is so small, it is negligible in an atom. Alright, so we do not consider that. If the number of proton is 19, then the number of neutron will be 39 minus 19, which is 20. Number of electrons is 19 here because in an atom, it is electrically neutral. The number of proton and number of electrons must be the same. So now we are confident that W must be 20, so option A and option B must be incorrect because here W is actually 19. So now let's look at the next row. Now we are going to work on ions of potassium, which is K+. Now over here, we see that the proton number remains as 19. Now take note, proton number of an element do not change. This proton number is a unique number to this particular element. If the proton number changes to another number, we must be dealing with another element. Alright, so the proton number is a unique number to the element. Nuclear number remains because when an ion is formed, there's only either gain or loss of electron. Number of neutrons do not change, number of protons do not change, so nuclear number should remain the same. Now, number of neutrons, it should be the same as the atom. Okay, again, as mentioned, protons and neutrons are not affected when ions are formed. Okay, only number of electrons changes. Hence, number of neutrons should remain the same as the potassium atom, which is 20, which is what we have worked out just now. Now we are at X, so which is the number of electrons. So now when we deal with potassium atom, we know that potassium atom has 19 electrons. So how are the electrons arranged? Now all atoms want noble gas electronic configuration, meaning if they only have one shell, they will want to have 2 electrons in this first shell. If not, they will want to have this octet structure, which means they want to have 8 electrons in their outermost shell. So now potassium, it has 19 electrons. The first shell will contain the first 2 electrons, then second shell will take 8 electrons. Third shell will take another 8, and the remaining 1 electron will be at the fourth shell. If this atom has 1 electron in the outermost shell, what potassium will do is, it will lose this outermost electron and then it will form an ion. And the electronic configuration of the potassium ion will be 288. Now a good way to check is, we know that we are comparing potassium atom and potassium ion. What we are concerned with is the proton and the electrons. We know that each proton has a charge of +1. Each electron has a charge of -1. Now for potassium, there are a total of 19 protons. So the total positive charge is actually +19. And this potassium atom has 19 electrons. So the negative charge is -19. So what do you think the overall charge is? If we have +19 and -19, the overall charge must be a 0. That is why we say that atoms are electrically neutral, because the number of protons which contribute to the positive and the number of electrons which contribute to the negative, they are the same. Now what about potassium ion? Now as mentioned, it is important to know that the number of protons of the same element do not change. Okay, so potassium ion should still have 19 protons. Alright, so it should still be +19. Now, number of electrons will be different if this particular atom changes into an ion, right? If potassium now has a charge of +1, it means that the number of protons must be 1 more than the electrons. Okay, so if we have 19 protons, the number of electrons must be 18, contributing to a -18. If we use +19 minus 18, we will still have a +1. This is another way for you to work out the number of electrons if you do not want to use the electronic configuration method, which we went through just now. Okay, so from here, we know that X must be 18. So with that, we know that option B and option D must be incorrect. And now we are left with C. Now for MCQ, I would recommend that you look into all options and double confirm that you are correct, okay, in case you make careless mistake. So let's check if C is definitely the correct answer by checking the value of Y and Z. So now we are dealing with ion of sulfur, okay, which is sulfide. Now in order to determine what is the value of Y, what we need to do is to add the number of protons and the number of neutrons together, because nucleon number, in other words the mass number, is the number of protons plus the number of neutrons. So we use 16 plus 16, okay? When we add these two values together, we will have 32. So C, Y is 32. Yes, that is correct. Now what about Z? Number of electrons in the sulfide ion. Let's compare the number of electrons in the atom and in the ion of sulfur. Now as mentioned, the number of protons do not change whether or not we are dealing with the atom or the ion of this element, okay? So number of protons in both cases are actually 16, okay? And that contributes to a +16 because one proton has a +1 charge. If we have 16 protons, there will be a +16 in atom and ion. Now let's determine the number of electrons. For sulfur atom, the number of electron must be the same as number of proton because atom is electrically neutral. The number of proton or electrons must be the same. Alright, so there must have 16 electrons, which contributes to -16, giving an overall of 0 charge in an atom. Over here, we see that the charge of sulfide is actually a -2, which means that the number of electrons must be more than the number of protons now. By how many? By 2. Okay, so the number of electrons must be 18. So 18 electrons contribute to a charge of -18. So -18 and +16, which comes from proton, will give you an overall of -2. So number of electrons must be 18. Okay, so Z is 18 in option C. So option C is definitely the correct answer. If you find this video useful, please like the video and share with your friends. Now don't forget to subscribe to the channel and stay tuned for more chemistry videos. If you'd like to have more chemistry resources, you may want to check out my website. The link is in the description below. Have fun learning chemistry, and I'll see you soon.